You are sleeping quietly in the dead of night. 1,600 kilometers away, floating on the pitch-black ocean surface, a Mark 41 vertical launching system aboard a Ticonderoga-class cruiser has just vomited a 3,000 degrees Celsius pillar of fire into the atmosphere. In exactly 2 hours, the heavily reinforced concrete ceiling hovering above your bed will violently evaporate into a blinding cloud of microscopic dust. The machine currently tearing through the cold night sky toward your exact GPS coordinates was not naturally born. Thousands of hours ago, America's most brilliant engineering minds meticulously grafted every single ball bearing, silicon circuit board, and chemical explosive block to construct a mechanical monster designed to live for exactly 120 minutes. Let us rewind the clock and step inside the sterile, freezing, brightly lit assembly line in Arizona, where your highly customized executioner was methodically forged. The birth of this autonomous assassin begins with the aggressive, deafening amputation of raw metal. Industrial CNC milling blades mercilessly carve into a solid, massive billet of aerospace-grade 7075 T6 aluminum alloy. These engineers are not merely building a simple cylindrical fuselage. They are carefully constructing an unbreakable mechanical ribcage. Every single friction, stir, weld connecting the fuselage sections must withstand tearing atmospheric pressures reaching 70,000 pounds per square inch when the cruise missile performs aggressive, evasive maneuvers at 880 kilometers per hour. To put that catastrophic force into perspective, the sheer aerodynamic stress hammering this cold metal shell during a sharp turn is physically equivalent to stacking 3 fully loaded school buses directly on top of a fragile wooden dining table. The hollowed-out aluminum cylinder is subsequently submerged and anodized in highly toxic chemical acid baths, a process that instantly transforms the shiny, reflective metal surface into a dull, matte, radar-absorbing flying tomb. But a perfectly aerodynamic empty hull is entirely useless without a stomach designed specifically for pure physical annihilation. Heavy hydraulic robotic arms slide the massive 1,000-pound DU-36B unitary warhead deep into the forward payload section with clinical precision. GT technicians wearing heavy protective gear slowly pour liquid BGM-107 plastic explosive into the steel casing under a strict high vacuum seal. This extreme vacuum casting process forcefully extracts every single microscopic air bubble from the deadly chemical slurry. If even a millimeter of empty air remains trapped inside the mixture, the intense friction of atmospheric re-entry could cause the detonation sequence to prematurely trigger mid-flight. Once cured into a solid, dense, rubbery mass, this stabilized explosive core guarantees a blistering shockwave velocity of 8,000 meters per second. When this concentrated chemical payload finally kisses the exterior brick wall of your house, it will instantly unleash a kinetic overpressure wave powerful enough to violently liquefy human internal organs within a 50-meter radius, long before the blinding thermal heat even registers on your unprotected skin. With the explosive stomach filled and sealed, the factory conveyor line moves forward to painfully graft the mechanical lungs. Engineers forcefully cram the Williams F107-WR-400 turbofan engine into a suffocating aft compartment measuring a mere 30 centimeters in diameter. This impossibly tight space is roughly the exact width of a standard ceramic dinner plate. Yet it houses an apocalyptic, fuel-thirsty propulsion system. Hundreds of ultra-lightweight, razor-sharp titanium turbine blades are meticulously bolted into the high-pressure compressor stage. During the weapon's terminal low-altitude sprint, These fragile-looking metallic pedals will be violently forced to spin at a terrifying 60,000 revolutions per minute.
Torque set to 150
The extreme physical
Newton-meters.
friction and massive
Confirming
air
blade
compression
alignment.
violently ignite
Sequence
the
complete on Sector
JP-10
4.
aviation fuel, pushing the internal combustion chamber temperature dangerously past 1,000 degrees Celsius. This sustained inferno is literally hot enough to rapidly melt standard structural steel beams into a glowing, dripping liquid puddle. The violent thrust continuously vectors out the rear exhaust nozzle, relentlessly pushing the heavy aluminum spear forward through the dense, freezing night atmosphere. The jet heart is now steadily beating. The heavy aluminum ribcage is sealed tightly shut, and the devastating explosive stomach is fully primed. However, a deaf and blind machine flying at transonic speeds is fundamentally nothing more than a suicidal, multi-million-dollar piece of flying scrap metal destined to blindly crash into the dark ocean waves. It absolutely cannot hunt you down without a highly sophisticated central nervous system. In the next sterile, dust-free laboratory room, technicians encased in white anti-static suits are preparing to permanently graft an unblinking optical array and a cold silicon brain directly into the missile's metallic skull. The mechanical monster is about to forcefully open its digital eyes, and it already knows your exact home address. Deep inside a Class 100 clean room, the atmospheric purity is aggressively controlled by massive industrial HEPA filters to violently eliminate microscopic airborne contaminants. A single, invisible speck of dead human skin cells or a microscopic clothing fiber floating into this highly pressurized chamber equates to a catastrophic mechanical failure. Engineers wearing full-body anti-static suits and wielding microscopic tweezers painstakingly assemble the inertial navigation system. A cold, heavy mechanical inner ear designed to feel the Earth's gravitational pull. The rapidly spinning internal gyroscopes and heavy metallic gimbals, often machined from highly toxic but incredibly lightweight beryllium, are precision ground to an astonishing physical tolerance of 0.0001 inches. To truly comprehend this maddening level of microscopic engineering, imagine slicing a single fragile strand of human hair into 10 perfectly equal vertical strips, and you have the exact physical gap separating these frictionless, spinning metal rings. If a microscopic dust particle ever breaches this hermetically sealed metallic housing, the resulting catastrophic friction would violently shatter the delicate gyroscopic equilibrium, instantly sending the blind, suicidal aluminum spear plummeting uncontrollably into a jagged mountain peak. But a flawless mechanical sense of physical balance is entirely useless without a pre-programmed geographical memory. The heavy silicon brain is violently force-fed gigabytes of heavily encrypted, three-dimensional terrain contour matching radar maps through a thick umbilical cable. This classified digital data stream physically rewrites the missile's internal memory banks with exact topological elevations of your surrounding neighborhood, mapping every single hill, valley, and concrete structure. When the Tomahawk aggressively drops to a terrifying altitude of 30 meters above the cold, damp ground to evade detection, a downward-facing radar altimeter actively paints the Earth below with rapid, invisible, high-frequency electromagnetic flashes. Traveling at a relentless, deafening 880 kilometers per hour, the internal processor frantically compares these real-time radar bouncebacks against the preloaded topographical memory grid. This aggressive, continuous digital cross-referencing sends high-voltage electrical signals to the heavy hydraulic actuators in the tail section. These actuators forcefully bend the aerodynamic control fins, physically dragging the heavy metallic spear through narrow, winding valleys and weaving underneath heavy anti-aircraft radar domes, exactly like a silent, predatory ghost hunting in the pitch-black dark. The final, most terrifying mechanical graft occurs at the absolute tip of the titanium nose cone. The digital scene-matching area correlation system is carefully wired directly into the central logic board. This high-resolution optical sensor acts as the cold, unblinking, predatory eye of the autonomous machine. During the final atmospheric descent, a small explosive charge violently blows off the protective nose cone cover, forcefully exposing the fragile glass camera lens to the freezing, rushing night air. In the pitch-black darkness, high-intensity strobe lights rapidly flash, artificially illuminating the cold ground below in harsh, contrasting black and white digital photographs. The silicon brain aggressively overlays these fresh, high-contrast images directly onto classified military satellite photographs secretly captured from low Earth orbit weeks ago. By mathematically correlating the exact physical dimensions of nearby paved roads, steel bridges, and specifically, the precise geometric outline of your concrete roof. This digital eye aggressively yanks the flight path trajectory. This rapid mechanical correction physically drags the terminal impact error margin down to a terrifyingly precise 10 meters after a grueling, fuel-burning, 1,600-kilometer atmospheric sprint. The unblinking digital eye has officially recognized the exact architectural geometry of your bedroom window. The terminal dive aggressively accelerates the heavy aluminum airframe to Mach 0.75, screaming through the lower atmosphere. The rear aerodynamic control surfaces lock tightly into a permanent, unrecoverable death dive. Inside the hollow fuselage, the highly stabilized BGM-107 plastic explosive core receives the final electrical arming current from the impact fuse. In a blinding, roaring fraction of a single millisecond, the absolute pinnacle of human aerospace engineering, advanced metallurgy, and microscopic silicon architecture violently erases itself inside a horrific, rapidly expanding fireball of catastrophic overpressure. This smoking, shattered concrete crater forces us to aggressively question a dark, uncomfortable reality. Did human beings master the complex laws of thermodynamics and advanced mechanical engineering to elevate our global civilization, or simply to manufacture the physical means to violently slaughter each other with absolute microscopic precision? Do not forget to subscribe to the channel and leave a comment below if you want us to aggressively dissect the complex mechanical anatomy of modern anti-ballistic missile interceptors in the next video.